Hi all, welcome back. Today we are going to discuss an important topic. It's a common topic for the class 9th and class 11th. And our today's topic is distance time graph. So in this class we are going to study about distance time graph. Distance time graph. There are two cases for distance time graph. In this class we are going to discussing about that two cases. Okay, what are that two cases? The first one is the distance time graph of an object moving with uniform speed. What's the first case? The distance time graph of an object moving with uniform speed. That's the first case. So what's the second case? The distance time graph of an object moving with non-uniform speed. Two cases, uniform speed and non-uniform speed. So what is meant by uniform speed? What are the peculiarity of uniform speed? In uniform speed, an object covers equal distances in equal intervals of time. In uniform speed, an object covers equal distances in equal intervals of time. But in non-uniform speed, it's not like that. That's the differences. So now we are going to learn about the two cases of distance time graph. It's an important topic. It's a common topic for class 9th and class 11th. Okay. Distance time graph. It's an important topic. Now we are going to discuss about the distance time graph. And our first condition is the distance time graph of an object moving with uniform speed. We already learned what's the peculiarity of uniform speed. In uniform speed, the object covers equal distances in equal intervals of time. So let's learn about the graph, how the graph looks like for uniform speed in the terms of distance and time. So we are going to draw the graph of distance time graph in uniform speed. It's the x-axis and it's the y-axis of graph. In the x-axis, we are going to take the time. In the x-axis, we will plot time, and in the y-axis, we will plot distance. So in the x-axis, we are taking time, and in the y-axis, taking distance. Okay, we already learned in uniform speed the object covers equal distances in equal intervals of time. That means in 5 seconds the object covers 5 meters, and in another 5 seconds the object covers another 5 meter. So covers equal distances in equal intervals of time. So how can we represent that in graph? Equal distances in equal intervals of time. How can we represent that? Let's see. The graph will looks like this. Okay, it's a straight line graph. So the distance time graph for an object moving with uniform speed will be a straight line from origin. Will be a straight line from origin. Will be a the graph will be a straight line from origin. For example, the object covers 2 meter. The object covers 2 meter in 2 seconds, and in the next 2 seconds, that means in 4 seconds, it becomes again 4 meter. Okay, that means the object covers equal distances in equal time. Okay, so once again repeat, the distance time graph for an object moving with uniform speed, the graph will be like this. What's the peculiarity of this graph? The graph is a straight line from the origin. Okay, in one axis we take time, and in the y-axis we plotting distance. Okay, one more point. What the quantity we will get from distance time graph? From the distance time graph, what the quantity that we will get? I think all of you know what's the formula for speed. Speed is equal to distance by time. So from this graph, from the distance time graph for an object moving with uniform speed, we will get the quantity speed. So from this graph we will get the value of the quantity speed. Okay, speed. We will get the quantity speed. Okay, so this all about the distance time graph of an object moving with uniform speed. It's our first case. Next we are going to study about the second case. What's the second case? Distance time graph of an object moving with non-uniform speed. So let's learn about that second case. Before that, you want to know what is non-uniform speed. What do you mean by non-uniform speed? Suppose if an object is in non-uniform speed. Suppose if an object is in non-uniform speed, it covers unequal distances in equal intervals of time. Suppose if an object is in non-uniform speed, it covers unequal distance in equal intervals of time. That means the distance covered is not always equal with time. That means the object covers unequal distances in equal intervals of time. So the distance time graph of an object moving with non-uniform speed is not a straight line from origin. So let's draw how the graph looks like. First drawing the two axes x and y. What's the quantity we will plot in x-axis? It's time, and in the y-axis we will take position or distance. So plotting the quantity, time, and here distance or position. Okay. Distance. So do you know how the graph looks like? It's not a straight line from origin. Why? Because the distance covered by the object is not equal. It's varying. It's varying corresponding with time. So the graph looks like this. Okay, from origin. So the graph looks like this. It's the graph for object moving with non-uniform speed. That means this is the distance time graph for object moving with non-uniform speed. It's the graph. Here we can see, if we are taking time 2 seconds, 4 seconds, 6 seconds, we can see the distance traveled. In 2 seconds, it's the distance traveled. In 4 seconds, it's the distance traveled. In 6 seconds, it's the distance traveled. From this, it is clear that in equal intervals of time, the object covers unequal distance. This is the peculiarity of object moving with non-uniform speed. So this is the distance time graph for object moving with non-uniform speed, and it's not a straight line. Okay. So these are the two cases of distance time graph. So it's an important topic in class 9th and 11th. So all of you prepare notes and study well. So let's see in our next class. Thank you.